the more you know, the more you can choose what you want to do.
Yeah, true. Thank you. It looks like a magic. Suddenly the answer comes out.
Yeah, it's like that. You know what I like? I didn't understand nothing about the prayer that we started with, but what I saw was growing trees and flowers, and that is the way the brain works, and that is the way everything that grows works. And also in mathematics, if you understand things really from the inside, then you grow. And the more you grow, the more you know. And
great. So welcome everyone. I think we have a record crowd today. So thanks everyone for joining in. So we have today Mr. Erik. So Erik is M.Ed, founder of Mathplay and the author of Mathjoy. Is a mathematics teacher who has specialized himself in 20 years in deep mathematical thinking, growth mindset, and game-based learning. So he's a national ambassador of the Global Math Project, Mathpickle and Kangaroo Math competition. So we welcome Erik. And this is going to be a really fun session. So over to you, Erik. Thank you for joining.
Thank you, Kieran, for inviting me. And thank you, children, for participating, because I never been teaching to 90 students from another country this way. So I'm really happy to be able to do this. And yeah, I hope you enjoy. What I would like to know about you is what age you are. So because I have no idea. I can't, I don't see everybody, but what are your ages? So I know a little bit more about you.
Sir, I'm 9 years old.
Okay. Maybe you can write in the chat, because I realize now that when 100 children will say their I didn't realize there would be so many children now. So I will look in the chat, and I see that the most are between 8 and 12. Is that right? Yes.
Could you tell me? Hello.
Okay. Hello. Wow, over 100, Kieran. So 15 also, 14. So thank you all. Thank you. Thank you for writing your age. And how many of you already know about a lot about fractions? Who think that who find fractions, working with fractions, easy? You can write in the chat. You say, "Oh, I find it easy," or "I find it maybe I find it difficult. I find it fun, or I find it hard." It's always okay. Nothing, but I'm curious, because here in the Netherlands, children find fractions really hard. So I see very, very easy. I see everybody writing. So maybe in India, children that's nice to see. Everybody says easy. So I will do a talk about fractions and about the visualization of fractions, and yeah, I will show you why here. So children find it sometimes difficult, and maybe maybe you can learn something from each other. So
excuse me, sir.
Yes.
I just wanted to ask you a question. It's not exactly related to math. It's like, what country are you from? I'm curious to know it. Because yeah, I know you're from Europe, but I'm a little doubtful as to which country you're from.
Which country I am from?
Yes.
Yeah, I'm from the Netherlands in Europe. So that's in Europe.
Yes, I was wondering you might be somewhere around Switzerland, Germany, and Austria from your accent, but yeah, I just wanted to confirm.
I'm from the Netherlands, yes.
Yes, thanks a lot.
So in this screen, you will see a picture on the background of children playing a fraction game, a domino fraction game that I sent to Kieran to use in a congress, and that was really fun. And now I also made another fun game with the fraction of pizza parts. And today I will be talking about them and also about how to draw fraction for yourself. So, I'll do the next slide. So I will talk about fractions as a ratio, why fractions are difficult, or at least we in the Netherlands, we think there's a lot of children think that. I will talk about the pizza problem and coloring in a square. What I want to tell is that what you say, what I hear is that children say here that fractions are easy, and I think that's because it's a really natural way of our brain from children from early age are really visual, so they see they can really compare easy. For example, if somebody takes some balls out of a box and they get three red balls out of a box and one white ball, then they will be expecting in the box to be more red than to be white. And that seems very obvious. And that is also the way our brain works. So we can really compare, our brain can compare fractions really easy. And that's really nice, but also sometimes it can be tricky. This is a photo from that day in those days that of the comparing fractions, and children had a lot of fun with that. So, but there we were comparing the images to each other, and now I want to ask if we want to compare the images with the fractions. Is that possible for you guys to do this? And
no, sir.
So maybe somebody that would like to give an idea about one or two to say, no, I think this one is that fraction. That's compared to that fraction.
Okay, I was just saying that I wanted to answer this.
Okay, can you answer one, please?
Yeah, sure. So here, as you can, I'll take the triangular one with the green triangle one. So so this one, what we do is we first count each triangle in them as you divide it into parts. Then we take the colored parts. So we put the colored parts at the top, and then the number of triangles at the bottom. And then with that number, we just simplify it and get it to a smaller number.
It's 5 out of 8. That's...
And you already know what the answer?
Yeah. Just 1 second.
So the answer is 5 by 8.
So it's I can write it.
5 by 8. The answer is 5 by 8. Can you hear me?
5 by 8.
Yes. So, but I think you first said 10 by 16 and then make it more little to 5 by 8, right?
And some of the fractions over here that cannot be fractions because fractions have to be equal.
So we saw this one because we say that was 10 by 16, 10 by 16, and then you can make it 5 by 8. So
yes, but the one of the ones, the hexagonal one that is diagonal to it, it's an unequal fraction. You can't. It can't be a fraction.
The third one, the blue one.
Yes, the blue one and the white one, the hexagonal one.
Yes, this one. And you, what do you think it will be?
I don't know what it might
Sir,
be
it's
because it's unequal. You can't do it because it's not a proper fraction.
sir, I think it's 1/2.
Well, the thing is, because I wanted to start this conversation to let you think about it. I will share the website where you can play this game, so then you can do it by yourself. But now it gets stuck. Click on the link in the chat. Can you play the game then on your computer? Does that work?
1 second. Actually, it's saying external site.
Yes, sir. It actually works. It works.
And if you click on the English flag, then you will get the English, because this is the Dutch flag, my nation's flag. And then I don't think you can read what it says because it's in Dutch. So English probably you can read. So if you click on that flag, then you will see the English. I understand that you understand how the game works and you want to try that yourself, and now you want to get more games, right? Is that true? Or is somebody that say, I don't understand how to do that? Okay, yes, I see thumbs up, so that's great. I think what I hear Avan say that he understood this one, but he thinks that the other ones are difficult, and that's true. There are really, not all will be really easy. But I'm sure that if you try it and you take more time, then you will find out that you can find a way. So, for example, if you see the one here with the, I want to draw on it. Yeah. Sometimes you need to draw extra lines to see that there are more, that you can make the same sizes. So, and that's also here. I don't know, you see the red lines I'm writing, right? Yeah. So it's really thick. I wanted to make it more thin, but then I hope you understand. You can draw lines, but the example I tried to show was the third one with the blue. I draw extra lines in them. So now there are all the parts are the same. So now you can count them again. But as long as they are not the same size, you can count them as same because they will be different size. That understood? So in this way, you could have said, okay, I have 3 blue and 6 whites, but they're actually 6 blues and 6 whites.
Sir, can I take the chance to explain them?
Okay.
See, in the triangle, how many triangles you have? Sir has drawn, they taken the picture, right? How many triangles are there? In green and white. He has shown the answer as 5/8, right? How many triangles are there, my dear peoples? My dear children, how many triangles are there? Count the triangles, number of triangles. Count the number of triangles. Can anyone answer? 16. Yes, exactly. 16 triangles are there. Out of that, how many triangles has been colored? Green colored. How many triangles has been green colored? 10. Yes. So therefore, take the ratio as like this. A colored triangle is 10 colored divided by out of that 16 triangles. So 8 and 16 are common multiples of 2. 8 and 16s are, sorry, 10 and 16s are common multiples of 2, right? So you can divide that by 2. So 10 is divided by 2 means how much you are going to get? 5. And 16 divided by 2 is 8. So that is the answer, 5/8. That is that.
Number 12 is 5 upon 12.
Which one?
Piece number 12. The yellow triangles.
Yes, this one is?
5 upon 12.
Actually, I think it's 5 out of 16 because if you draw the triangles, there will be 16 triangles, like the ones here, the green ones. We just
as it was in green one.
But it's not really it's not bad if it don't work immediately. Just try to play with them, and you will learn more. So I go to the next. To go further, that fractions are dividing problems, and sometimes it's depending on the situation what you try to solve. Like here, for example, we have cherries, 20, and we want to divide it by 4 people. And the other situation is we have cherries, and we want to put them in bags of 4 cherries. You see that the way you will divide, it will be a little bit different, because in the left one, you want to divide the cherries. You will give here a cherry, there a cherry, there a cherry, there a cherry, and then you give all the time 1 cherry. On the right, you will get bags of 4 cherry all the time out of the situation. So it will be a different problem, but still it will be the same answer. You know what the answer is? So how many cherries will be getting every person here?
5.
And how many bags of 4 cherries you can get out of 20?
5.
5.
5
good.
to everyone.
5, sir.
So that's 5. Yes. Really?
5, sir.
Yes, everybody knows it. Yes.
5.
But it's the same situation, only a different way of looking at it. You can see that?
Yeah.
Yeah. Okay. That's why sometimes working with dividing is a problem, because it's like you look at the one side or you look at it another side. You know, this is like ways of looking at a fraction, and I made a pizza puzzle out of it. So you can look at it as a division. So you have 2 pizzas and you have 5 children and you want to divide it equally. Or you say we have 5 plates and you want to put 2 pizzas, and how you will divide them. Or you have 1 plate where you put the parts of the pizza that you were supposed to get. And yeah, the fractional number that's in the situation, that is the 2 divided by 5. So there's different ways of visualizing the same. And so those 4 cards on the left are the same situation. And the 4 cards on the right are the same situation. Do you understand that?
So do you mean we have to like on the right, there's 3 by 4. So we have to find on the left is any constant by 4 should be matched there.
I hear somebody talking, but I didn't hear good what she said.
Yes, we are able to understand.
Okay, so also here you can try to make, I have a game that I will share in the chat. And there you can you have to make the quartets of the quartet. It's like 4 that will be together. So maybe I can try to share that. We can do that together. So I have here the situation. So here you can change pieces with another one. So for example, here I have 2 divided by 3, and this is a situation where you have 3 plates and you have 2 pizzas.
But we have to put all same fractions in a box.
There's 1 quartet, and you have to make you have to try to get them. So for example, the 2 divided by 3 is the this one. So I want to put them in the same box. And so here is 2 divided by 3. So now I have left of this is one that is completed. So I have to make them all complete. So this one is completed, and so I can go on. So now I can try to make this one. So this is a half. So I have 1 pizza that's in the half, and then I have 1 half, and so I can look which one this is. This one, and so I need still one that is with the
Sir, that works in a section row.
This one, yeah. So I can make them all, and then that way you are connecting the visualizations of the fractions in different ways to each other, and you make connections in your brain to really get more accustomed to the situation that those visualizations they are actually a nice way to make the connections in your brain that are similar situations, and then you get more accustomed to that. And later, when you get more problems about fractions, you will feel more comfortable. So this is a nice way of getting them connected in a fun and easy way. The way this is the way that the cars will be from low to high. And you see on the top part of the screen and the down part of the screen, there's a different way of looking at it. For example, if you want to know when you will have more pizza, well, if you have 5 pizzas with 6 people, you will almost everybody have a whole pizza. So that's a lot. That's a lot. And if you have 1 pizza and you're with 6, then you have the little part. You don't have so much. But what is more if you have 2 pizzas with? You can understand that left and right are exactly the same part colored of the in the left image. There's a blue section colored, and in the right part is a green section colored, and in both squares exactly the same ratio is colored. Can you understand that?
Yes.
Do you believe that?
Yep, we can understand it.
No.
Hello, we can see. Yes, sir. We can understand.
Is it because you feel that, or is it because you can prove that also?
Sir, I didn't understand this problem. Please explain again with an example.
So, if I want to know which part of the square is colored and how much of it, how much paint I need, and in the right part, I also need paint. Is there more paint green or more paint blue?
Sir, voice is not coming clearly.
Okay, the question is, so you have 2 pictures, right? So do you think if you have to paint these 2 pictures, do you need the blue paint more or the green paint more?
Equal, sir.
Okay, and do you know for sure?
Yes, sir.
And can you prove this?
Sir, it is easy, sir.
Okay, but we wait maybe till everybody, because Krishna knows and says it's easy, but the other people, other children.
But I think so. It's equal. I think so. It's equal.
But you know for sure, or you think?
I'm a bit sure.
Okay. What makes you think that that is equal?
The way they look. I feel the way they look, because the way they represented, it's like it's the difference of the way they've divided it and the places where they colored it. So when you see it straightforward, you see that these parts are they're divided, and then you see how the color they've used. So you can, in a way, in your mind says that it's equal.
So actually,
Yeah, and it's you can prove this, but your mind already does it. I think your mind does fill in, but I don't know if you rationally know that you can really yes.
So I think I can know how to prove it. So yeah, for the first photo, there
Yes.
if you the bottom part, if you make it half and just
Yes.
put this part on the left side, then it fits perfectly on the curve.
Yeah.
So then it makes half, and this next one again, the
Yes.
bottom left part. So if you make that half, so there'll be two curves. When you fit the curves in the other two curve holes of the top right part, it fits perfectly. So both of them are half of the square.
Yes, and here is the top half, and here is like the half diagonal, but it's still the half. So that is like your mind can, that is the way you can do this, and yeah, really good. So you can, they are really difficult ones that I also made for the ones that are really, yeah, are 14 or so. I can share this one also, but this is really difficult. But you can try to compare also these kinds of shapes to each other. So we'll share this one. But this is really, to be honest, this is a bit difficult, but like the other ones were, yeah, we have children from all kinds of ages here. So I wanted to, yeah, I want to give a nice exercise for everybody. So if you think it's too difficult, don't worry. If you think you want to try, it's okay. It's always good. Just, yeah, for everybody to be able to do something. Okay. My question that I wanted to ask you is this: which kind of fractions can you make? Can you color in a square by using only lines from corners and midpoints? So, for example, I will draw now. I will give some ideas. So I have to do the whiteboard. So, if I draw a square. So, and I can only use, no, I can only use these parts. Try again. So I have a square, and then you can draw lines in them, but you can only use the midpoints or the endpoints. So if I, for example, draw a line so, and I draw a line so. So one so, and also one. Okay, so if I have this situation, and then I color this part, so that's not nice to draw. So if I would draw this in, how much of the square I would have colored if I color in all this? Can anybody answer that? So this this part, how much of the square I colored now? Yeah, if I did that nice, but
sir, 2 by 1. Half part you have colored. Not correct half.
Sir, could you repeat
3
the
by
question?
4.
Hello, could you
you
repeat
write
the
it in the
question?
chat. I hear the
1
answer.
by 2, sir.
So could you repeat the question?
Which part is colored of the square? So which ratio?
3 by 4.
3 by 4, Harshal say. Yes.
1 by 2, sir.
It's not 1 by 2. It's 3/4 of the square is colored.
By 4.
Because if I can make of this white, I can fit 3 in the red piece. I can fit 3 of the whites. So I have 1 is white and 3 are red. So in total we have 4 parts. So 3 of the 4 parts would be red. And my question is, which kind of fractions you can make, you can color with just using lines that end in the midpoints or in the corners of the square. And that is that I would like to, that's a nice investigation. I really found a lot, but I didn't find all. So I'm curious which one you can find.
So could you repeat your question?
So which fractions you can find by coloring parts of a square using only lines that start or end at the corners or the midpoints of each side.
Okay, can we use more than 1 or 2 lines?
Yes, you're able to use as many lines as you like. So, for example, I can also I make another one. How I do that? Okay, so I will try another one. Then I make a line. I do like this, for example, so, and then I use a line like so. So, and then I do another line like maybe so, so, and then also so. Where's that other one? So, for example, I can also say now, okay, but this is maybe difficult, but how much this part here? So, what fraction is that?
The blue color line, you mean?
Which part?
Okay, yeah, I understood.
No. Difficult. So, and this is also the end of this this hour. So I have to end with something that is interesting, right? That is for everybody a nice way to think about. And I would like to know what kind of fractions you will find, and then maybe share it with Kieran, and Kieran can share it with me, because actually I make always games, and maybe I use your drawing in my game, and then I will let you know. So if you find some nice fractions and you send them to Kieran with your name, and if I ever use one of your drawings, then I will share it on the internet, saying that thank you to. Because I really like that you keep a mindset that is trying to investigate. Like mathematics is not only about calculating; it's about investigating. And this is something what I will ask you to do, is to make your own investigation in how I can make fractions visual. So I hope.
Do you have a website? So if I go to that website, I can play any of the game I want.
I'll share a website that is from my friend who makes them, because that is this one. Can you see this?
Yeah, we can.
Yes. So this is in Dutch, but if you are on this website, then you can just see, and if something likes, then you just click on it. You just try it. Sometimes some maybe are difficult and some maybe are too. Just look at it, and if you have questions, you can always email. I will send you the link to this one. In the
does anyone have a question? So Eric will answer any questions that you have. So anyone having any questions on fractions, right? So you have any questions on fractions from either your curriculum or otherwise, right? So
fractions, there are greater numbers and smaller numbers. So we find their LCM to find which is greater, which is smaller. But then when it comes to bigger number, it is a bit difficult to find their LCM and do it. So is there any other smaller way to do it? No, I wanted to find if there's an easy way to check which fraction among 2 or 3 numbers is greater or smaller.
Yeah, that's really nice. Yeah, that's a really nice problem. So, for example, if I ask you what is you have 2/3 or 3/7, which is greater or smaller? If you want to know, this is not maybe I.
2/3 and 5/7, right? 5/7. So we just find your LCM and then do it. So the greater number for the second problem is 5/7. The greater number for the second problem.
And how you do that? What is the way you do that?
So LCM is one way which we've learned in school to do this. But then for bigger numbers, as it keeps on increasing, it's really difficult to find their LCM and then multiply it off.
Well, what I wanted to show, what I tried to show in the in this one is that sometimes I don't know why it's. Sometimes you can look at the denominator or the how you call the other one.
Numerator.
Numerator, yeah, numerator, denominator. So you can sometimes you look at the in the top screen you look at the denominator, and in the numerator. Which one is the one down?
The down one is the denominator and the top one is the numerator.
Okay, so you see that when you compare all the ones with the same numerator, that if the denominator gets smaller, the fraction gets bigger. So 1/3 is less than 1 second.
Yeah.
So if I have one third or 1/4, which one is more?
In 1/3 and 1/4, obviously 1/3 is bigger.
Yeah. But if I say I have 3/5 or I have 4/5, which one is bigger?
I say 4/5.
So when you look at the one, it's the other way around. So sometimes when you want to compare fractions, you don't really have to make the denominator the same if the numerator is the same. So sometimes you can. It may be more easy to, if you want to look at, for example, if you have 5/99 or so, and you have I don't know 10 1. So this one, if you want to share, if you want to know what is the biggest, what you can do also is you can do, I make from the 5/99, I will make that into 10 198. Yeah. If I have 5/99,
okay,
then I can multiply the denominator and the denominator by 2.
Yeah. So 5 will become 10 and 99 will become 198. Yeah, true.
So if I wanted to compare 5/99 with 10 176, then I can also say, okay, that then I want that the same as comparing 198 with, if I had 1098 with 10 with this one.
Yeah, true.
So which one is bigger?
So in this one, I'll say 10 176.
True. So you see, you don't have to make the denominator the same. You can also look at the numerator. It's not like it's always the same in math. You can use your brain and you can use your imagination in the situation. So just follow your feelings and just know the things you have to do. But if you, the more you know, the more you can choose what you want to do.
Yeah, true. Thank you. It looks like a magic. Suddenly the answer comes out.
Yeah, it's like that. You know what I like? I didn't understand nothing about the prayer that we started with, but what I saw was growing trees and flowers, and that is the way the brain works, and that is the way everything that grows works. And also in mathematics, if you grow, if you understand things really from the inside, then you grow. And the more you grow, the more you know, and the more you can understand. And don't ever think that the way it's supposed to be, there's not a way it's supposed to be. The way it comes when you understand. So really try to always understand what you do, and then you will grow.
Thank you, sir. I really love this problem. You showed a square and then you drew the midpoints one, right?
Oh, and you want to know what is the answer of that? Oh, now I understand. Yeah. So I draw. I will. Oh, okay. Then I think I understand. So I drew a line, and then I do a line. So I think I did this one, and then I did this one. Okay. No. This one. So I draw a line. So in the middle, and then I draw a line. Oh, no. And then I draw a line. This program is, I'm not really good in this program, but I draw a line like so. And then I said, what is the, how much is is colored, right? That is the question, I think, Kieran, right?
Yes, sir. Yes. Correct. That's the question, yes.
Yeah. So,
can I answer?
Yeah, I can also answer what you want. But it's okay. Yeah, Samivita, if you want, then it's okay. Yeah, answer.
That's 1 by 16.
Yes, and how you know?
So first you draw a line in the middle.
Here? So? Oh,
So
where you want?
vertically.
Yeah, so what I did? Yeah.
So vertically. In the middle, from the midpoint to the bottom midpoint.
Yeah, yeah.
And then you draw a line from the other half, the bottom half. The
Yes.
bottom half from the corner of the bottom half and to the
bottom to the top right
diagonal
side.
corner of the bottom half.
So I didn't hear. I didn't. So I draw the line, this one, and then you say from this point where I have to draw.
To the left midpoint.
Okay. To the left midpoint. So, like this? Or so?
No. From the right bottom. So to the other end. Diagonal to the other end. Right bottom.
Okay, to the right bottom. So.
Yeah, like that.
Yes.
Sir, so in the square which is colored, it has 4 parts and all the other 4 parts are equal. So the total, there are 16 parts like this, and so out of that 1 part is shaded.
Yeah, I'm totally agree. Only one thing, that is how you know for sure that I mean, I see the red one. I see that the red one here is equal to this blue one if I draw. What I don't see for sure, and that's what I want to know for sure before I can say it's totally true, is that this yellow one that I'm drawing now is the same. It's the same because oh, no, I don't draw. I want to draw the yellow, but so that this yellow, it has a kind of a different size. But why you know for sure that it's the same size as the red? That is the only question that I have, because it's not the same shape.
So I'm not sure. I need to investigate.
Yes, and I can give you the answer if you want, or you can investigate by yourself.
I'll do it myself.
Wow, that's really, I love that. Yeah, and if not, don't work, you can email me or you can ask to Kieran, because actually they are the same size. But good, and you will find that out, and if not, then you will get help. But first try out yourself. Really good.
I think, see, in school, we always used to, I think that question Deepta asked, right? So the mindset is always, okay, look at the denominator, right? But, you know, in math, you can be innovative, like Erik mentioned, right? How we can actually make the numerator same and still make the problem a simple one, right? So that was so lovely. Right, so I mean, math is all about that, right? Now, how we can really use our imagination and really solve the things instead of really, you know, going with a structured, fixed way of doing things. I think that was lovely, and the puzzles that we went through, I think I I think I want all of you to really try this Sunday afternoon, right? After your lunch, go to the website and try this out. And so Erik actually had sent this game to me, and we had displayed in the VIT museum, like 2 years back. And a lot of students who came, they're like, the first question I actually asked them is, do you love fractions? They said, yes, I love fractions. And the moment they started doing this, they were really fun. I mean, they were not giving up because it appeared easy because it was fractions, but the moment they started doing it, it was not so easy, right? So, but it was fun. Like, the students who came there, they never left the place, the table, till they solved the whole thing, right? So it's very addictive. So I'm sure, after your lunch, just go to the website and play all those games. It's really fun.
Which game is it, Kiran? Which game is it?
The domino game, like
Domino.
Yeah, the fraction dominoes.
Okay, is there any online link for that?
Sir, I will play dominoes
Yes.
so many
Okay, can you
times.
share the online link?
Yeah, I will share the link. I think Erik mentioned it. There is one website where all the games are there, so I'll share the
Okay,
link.
that's the same one. Okay, all right.
It's the same thing. Like, you can go to the
Sir, I will play the game so many times.
Yeah, you can play the games, and I'll also send the sheet that Erik has forwarded. So I'll share with all of you. What you can do is, if you have a color printer at home, you can just take a printout and you can cut them in as per the instructions, and actually you can start playing like a domino, like how you play dominoes, right? Like how do you make a chain? So you need to make a chain using them.
Sir, sir, put out one piece of dominoes game.
Yeah, I will send out in the WhatsApp group, right, the image. So you can in the Math our WhatsApp group, I will share that game. Okay, great. So I think this was a wonderful session. I just loved going through all those games, and I hope all of you enjoyed the game. And Erik, thanks a lot once again. I know it's like early morning for you, but thanks for joining in. And today we really